Well, Pete, it's now June and the shortest nights of the year are upon us, but there is plenty to see in the night sky and indeed in the evening sky. So let's start off in the inner solar system. And this month, the planet Mercury is in our evening sky, but it is now heading back towards the sun for inferior conjunction, which occurs on the 11th of June. And we've just had a great period of
Yeah, it's
evening
been really good,
visibility.
hasn't it? Yeah.
And now we're going to pay for that because Mercury's about to disappear.
It's getting quite dim actually. On the 1st of June, it sets about an hour after the sun, but it's about magnitude plus 3.2, and that makes it really difficult to see against the bright evening twilight. And of course, after inferior conjunction, which occurs on the 11th, Mercury will return to the morning sky, but it's not very well positioned. So I think if as you get towards the end of the month, it's about magnitude plus 1.1, rising about an hour before the sun, but that low altitude will compromise its visibility quite a bit.
Yes, I think it's going to be a tough target. Moving further out, then, the planet Venus. This also is an evening planet. It now sets 1.5 hours after the sun on the 1st of June. And this doesn't really change much throughout the month. We're in that period in Venus's orbit where it sort of languishes at about the same brightness and altitude for a while. It'll get better later on in the year, but it is quite low down at the moment. And of course, it's quite far away from us. So small apparent diameter and a large phase. However, I should say, as Mercury Venus section director, we have started receiving observations, and I'm grateful for people who do that and send them in. And some of the images recorded do show some nice cloud structures in the upper atmosphere, and some of the visual observers have seen that as well. So it's certainly an interesting one to watch, but it is tricky to get at.
It is an interesting one to watch. We should point out that Paul is the director of the Mercury and Venus sections in the British Astronomical Association. Not the universe, as he implied just now.
I didn't imply the universe at all. Okay.
Yeah, but if you've got the ability to locate Venus during the day, of course, which is probably the best time to see it, it reaches a maximum altitude of around 58 degrees when due south at 3 o'clock p.m. on BST at the end of the month. But its phase is actually quite large at the moment. So on the 1st, it's about 95% lit, and then on the 30th, it's about 90% lit. So it's like a little full Venus, isn't it, if you can find it?
Yeah, it'll take a while for that to reduce to a phase that we sort of like to observe more frequently. But yes, but it is there, and it is, as you say, a good time to find it in the daytime when it's at a higher position in the sky. And of course, be very careful with the sun if you're going to try that. Further out then, planet Mars. This is still lingering in the constellation of Gemini, still lingering on, but it is now quite small. Planet is only about 3.9 arc seconds by the end of June. I made an observation. We're recording this actually in April, and I made an observation of it on 28th of April with my 12-inch telescope, but I could still see some vague surface features with my 12-inch Newtonian, but it's becoming incredibly difficult, and that was at 4.7 arc seconds. So once it drops below 4 arc seconds, I think it's going to be pretty challenging to see anything at all.
And it hangs around for a bit, doesn't it? As it sort of compensates.
Teasing. It does have. It's a shame because it does actually have a couple of nice close encounters. For example, it's right in the heart of the Beehive cluster on the evening of the 23rd of June, but it's practically in the daytime. I mean, it's going to be a dusk sky, and it's going to be very difficult, I think, to pick out the stars of the Beehive cluster photographically as well as visually.
Yeah, that's right. But there is a nice encounter with an 11% lit waxing crescent moon, which passes 2 degrees to the north of Mars on the evening of the 13th of June. So the moon's easy to find, especially at 11% phase.
Yes.
So look for Mars below it. That's maybe your last chance to see Mars easily at that point. What about Jupiter then? Well, Jupiter rises 3 hours before the sun at the start of June and attains a maximum height of around 20 degrees above the southeast horizon as the sun rises. The moon will be quite close to Jupiter on the 1st of June and on the 29th of June as well. So that's another indicator. Although Jupiter's difficult to miss, isn't it? Really, because it's pretty bright.
Yeah, I mean, it's a very, very bright target and a lovely yellowish colour. I always think it is quite striking. And the altitude this year is actually much better. Jupiter is slowly moving out of the southern skies and climbing up. So that's good news for UK-based observers. And we have an interesting phenomenon happened because Jupiter reached equinox on the 2nd of May. We can now look for what we call mutual events, this phenomena whereby the four Galilean satellites, Io, Europa, Ganymede, and Callisto, pass in front of each other or behind each other, eclipsing each other, not just the moons, but their shadows as well. So there's some nice phenomena to watch out for.
Yeah, we're reporting on a number of these in the Sky Guide in the magazine, so look out for them there. And of course, there's also an opportunity to see Callisto interacting with Jupiter, because away from equinox, Callisto's orbit is tilted enough that the moon misses the planet. But at equinox, basically the orbits appear like a line, so the moons move backwards and forwards on a line either side of the planet. So Callisto can actually move behind Jupiter and in front of Jupiter and cast its shadow on Jupiter. So that's not that common a sighting. So that's something to look out for as well.
It's actually quite rare, Pete. If you think that we only get these equinoxes every 6 years or so, add to that Jupiter has to be, reasonable altitude. You need a clear night, and Callisto takes a long round time to orbit Jupiter.
Yes,
it actually becomes quite a target to try and catch, because there can be a long time before these events happen.
Yeah,
in fact,
that's true.
I think I've only got 2 drawings in 25 years of observing Jupiter. I think I only have 2 drawings showing Callisto's shadow on the disk of Jupiter. That's how rare they are.
That's an incentive to go out and actually have a look for them. Okay, well, let's move on to Saturn then. Well, Saturn is a slower mover than Jupiter. And if you remember last year, Saturn and Jupiter were really close together. So as Jupiter is now moving further east and climbing higher in our sky, as we've seen from the UK, Saturn is doing the same, but not doing quite as well. And it is improving, though, which is a positive, because it's been getting worse for an awfully long time. So now it's actually in Capricornus, and it's able to reach a peak altitude of 19 degrees, as seen from the centre of the UK, which isn't brilliant, but it's a definite improvement over the 14-degree peak we had back in 2018.
Yeah, we're slowly getting with Saturn back. Of course, because it takes Saturn 30 years to orbit the Sun, it spends an awfully long time in each of the constellations that contain the ecliptic. So that's great when it's in the northern constellations, but when it's down south, it feels like Saturn's gone for a very, very long period of time. But as you say, it is climbing higher. And of course, the rings are starting to close up now. So we should be able to see a little bit more of the southern hemisphere just peeking out above the rings.
Yes.
This year. And I often find when Saturn's in this kind of phase, but when it's in this kind of orientation, you can detect a slight greenish hue to that hemisphere just above the rings. So that's certainly something I'll be watching out for.
Yeah, that's interesting. Well, okay, the ice giants then, Uranus and Neptune, we can deal with those very quickly because they're not really that visible this month. We're going to have to wait until we get a bit later on in the year. But there are quite a number of special events which are worth mentioning in June, which is surprising, seeing as we've got such a short period of night. But of course, June represents the first major half of Noctilucent cloud season. So this is a great time to look for these high altitude ice clouds. They can be visible at any time, but typically they're visible in the evening, about 90 to 120 minutes after sunset, low above the northwest horizon, or a similar time low above the northeast horizon before sunrise. And if you get a good display, they will appear above the northwest horizon and then drift through north and then disappear as the sun starts to get higher below the horizon. So they disappear in the northeast. So they can be pretty spectacular, can't they?
Yeah, we've had some great shows here, and even here in Leicester, where we've had some absolutely splendid displays. And sometimes when they've appeared in a slightly unusual place, Pete, that time that they were over in towards the west when they should have been further round to the east. And do you remember that? I telephoned you and you didn't believe me.
That's the other way round, actually. Yeah, it was early evening,
That's
and
right. Yeah.
you called me and said I can see them over towards the northeast, and I said you were talking rubbish as
That's a
usual.
polite way of saying what you said.
And actually, they were over towards the northeast in the early evening, which is quite remarkable. So they don't always play by the rules, and they can actually get to a reasonable altitude. It's always said that they're very low down. As we see them, but actually, I've seen them creep up in the early morning to go overhead.
Yeah, they
Which
can.
is
They
quite
can get
remarkable.
quite high. Well, on the 5th, then, let's do some of these events. On the 5th of June, we've got two shadow transits which occur on Jupiter's disk on that morning. So Jupiter rises after 0030 UT, so 130 BST, and Io and Ganymede, both of their shadows will be concentrically overlaid on Jupiter's disk. And now Io moves much quicker than Ganymede, so Io's shadow will appear to speed off, leaving poor Ganymede's shadow trailing to exit the disk at around 0317 BST. That's quite nice.
Yeah, it's a bit frustrating actually because we're not going to see the concentric overlay of those two shadows because Jupiter will be rising as that occurs, so it's just going to be too low, which is a real shame. But if you were further towards the east, over in Europe, then you would be able to see the shadow of Io catch up with Ganymede's shadow and then pass through it, and then come out the other side, which would be quite something.
Oh, that would be wonderful. I would have loved to have a drawing like that, but
Not to be.
not to be. But I'll see if I can catch that one anyway.
Yeah.
On the 6th of June, asteroid 3 Juno reaches opposition. That's located in the constellation of Ophiuchus, the serpent bearer. Juno shines at magnitude 10.1, so you need a telescope to be able to see that.
Yeah, okay. On the 9th, we've got a thin 1% illuminated waning crescent moon just managing to clear the northeast horizon before sunrise. That's a challenging target requiring a good flat horizon in that direction, but something interesting to look out for.
Yeah. Well, on the 10th of June, we've got a couple of interesting things. In the morning, we can catch Jupiter after it rises, and that's about quarter past midnight UT or quarter past 1 BST. And as it rises, if you turn a telescope onto it, you'll see outer moon Callisto in transit. So that's a nice thing to watch. But of course, the main feature is later on that morning is the partial solar eclipse, which will be quite exciting.
It will be exciting. It's a morning event. You can see the times in the magazine. All the details are in there. But it's first time we've had a solar eclipse for quite some time from the UK. So it's definitely something to worth looking out for. You need to take great care when you're observing it, of course, because you can damage your eyesight. So you need to use a proper certified filter, or possibly the easiest way to observe it safely is to use a piece of card with a 1 to 2 millimeter hole in it, where you hold the card up to block the sun's light and allow the light coming through the hole to fall on another white piece of card. So that will actually show the shape of the eclipse. So that's an easy way to follow the event. But obviously, if you've got telescopes and whatever, you can observe it or image it with telescopes. Just take care and make sure you use proper filters.
Well, let's hope that we have clear skies for that. And how much of the sun will be obscured, of course, will depend on your location. Scotland will get quite a lot, so 49.2%. But unfortunately, if you go further south, then that will decrease quite rapidly. And in fact, the eclipse will only be total in the far north, well beyond the UK.
Yeah, that's right. It's actually the 49.2% should explain is the how far across the sun's disk the moon manages to get. So it's almost halfway across the sun's disk from the northwest of Scotland. And if you're in Dover, it's about 30% across the sun's disk. So the further northwest you are, the better. In fact, if you happen to be in a very narrow path running up through parts of Canada, through Greenland and into Siberia, you would see what's called an annular eclipse of the sun, where the moon is too small to actually fully cover the sun's disk, but it will appear to pass inside the sun's disk. So if you're in the exact right position, you'll see at a certain time the moon concentrically inside the sun's disk. So that creates a little ring of light around the moon, which is called the ring of fire.
I've yet to see one of those.
Have you?
No, I've never seen an annular eclipse. Plenty of totals, but never an annular eclipse. I'll have to make more effort.
Yeah, we did one for Sky at Night, I think, back in, oh, crikey, it's going back a bit, 2005, 2006, something like that.
Always before I joined, yeah.
And we did it from Madrid, and it's an interesting event because if you didn't know it was happening, even at the point of annularity, you probably wouldn't think there was an eclipse going on. Depends on the magnitude of annularity, because you get different types of annular. The moon is really small. Sometimes it all just fits, so it's almost like a total. But this one had a very thin annulus of light around the edge of the moon, but it was, the light had a weird twilight effect to it, but it wasn't anything that noticeable. You could easily walk around and just ignore it and think that it was just a bit of an odd light going on.
Or maybe just a cloud was passing in front of the sun, something like that.
Yes, that's right.
Yeah, I'd hopefully look forward to seeing one at some point. We also have a nice pairing with the Moon and Venus on the 11th. If you locate magnitude quite bright, -3.8 Venus, low above the northwest horizon, 30 minutes after sunset, you'll see a very delicate 1% illuminated lunar crescent just under 5 degrees from Venus in the direction from where the sun sets. That'll be quite nice, particularly if you like looking for these thin crescent moons.
Yeah, and if you don't manage to see the moon on that evening, don't worry. Then you can try again on the 12th, because if you can locate the moon and Venus around 06:30 BST, so this is the morning. So this is after you've tried on the 11th, gone through the night and into the morning. Try and locate the moon and Venus again in the daytime sky. Then they will appear just 42 arc minutes apart.
That's not far, really. It's quite good.
It's going to be tricky because the moon isn't going to have a big phase at that time, so it will be hard to see, but worth having a go for, especially if you've got the facility to locate Venus with setting circles or whatever your setup is. It's quite an interesting thing to look for. And by the time they're visible again in the evening sky, around 22:30 BST, they'll be 6.3 degrees apart, so they don't stay together for long.
No. Okay, well, on the morning of the 12th, Ganymede and Io's shadows, so two satellite shadows, are in transit on Jupiter from 0340 BST onwards.
Yeah, well, that's interesting. And there's actually another event on the 26th where the shadows of Io and Callisto will be in transit on the morning of the 26th. So Callisto's shadow starts first from 0440 BST, with Io's shadow joining in just after 0600 BST under daylight conditions. But you can see them under daylight, can't you?
You can. I've never tried, but I might do this year.
Okay.
Yes, you can, yeah.
Well, the sun is at its solstice, the summer solstice for the northern hemisphere, of course, is at 0432 BST on the 21st of June. So that will affect the nights. And June is a testing month for astronomy because the nights are so short for us. But there are a number of, let's describe them as less distinct constellations which try to take centre stage. But we do have some strong patterns of summer, but they're probably better seen next month, actually, as the nights are so short in June. And I think the best way to describe it is the view is dominated, if that's the correct way, sort of towards the south by two giants of the night sky. You've got Hercules, the strong man, and Ophiuchus, the serpent bearer. And Hercules is a relatively faint, and it's quite a large constellation, isn't it?
It is quite large, but the keystone, I always think, although the stars that mark the keystone asterism aren't really bright, I think you can easily recognise it even if skies are a little bit hazy. I've never had any trouble in picking it out.
No, that's right, and that's formed from Epsilon, Zeta, Eta, and Pi Hercules, and it's not a very bright asterism, but it does stand out fairly well. And of course, that's a great guide for locating the Great Globular in Hercules M13, and that's something which is well worth looking out for if you have a telescope. And it rewards any size of telescope, really, but a big telescope is quite a phenomenal thing to look at.
It is. So I've looked at it with many telescopes over the years. My original 4.5-inch reflector resolved some of the stars on the outer core. My 8-inch, I think, resolved it down to the core. But my current 12-inch telescope, it's just it almost has a 3D effect in a dark sky. It really does look
Yeah.
like a huge volume of stars in a sphere. It's quite an impressive sight.
Well, the head of Hercules is located at the southern extremity of the constellation, and it's marked by the star Rasalgethi, Alpha Herculis. Hercules rather, is upside down in UK skies, and it's fortuitous actually where Rasalgethi is located because it's quite close to another head star, which is well, it's pronounced in different ways, isn't it? Rasalhagu or Rasalhague, I call it, which is Alpha Ophiuchi, and that's the head of Ophiuchus the serpent bearer.
Yes, it is a straight. I've always pronounced it Rasselhague, but I suppose there are other ways of doing it. Ophiuchus is an interesting constellation. It's not a particularly bright constellation, is it? But it does have a sort of squashed pentagon look to it. That again, not like Hercules, not very brilliant stars, and certainly not striking. But once you've seen it, you can't fail to recognise it, I think.
No, it's. I've always understood it to resemble an upturned flower pot,
Yeah.
which is, if that makes any sense. But
No,
it's
it doesn't. But okay, I'll let you have that one. I don't see an up to flower pot. A slightly squished ellipse is a flattened
squished
ellipse.
ellipse. No, that's completely wrong. So you got it's an upturned flower pot with two legs dangling from the southern corners of the pattern. That's the best way to describe it. So Ophiuchus contains a number of interesting globular clusters, including M10, M12, and M19. And off his eastern shoulder, he plays host to IC 4665, which is quite a nice, large, and relatively bright open cluster, 1.3 degrees north of Sebel Ray, which is Beta Ophiuchi.
Yes, and if you look 4.5 degrees east of Sebel Ray, providing the skies are fairly clear, you should be able to see a faint sort of V pattern shaped stars that are rather reminiscent of the Hyades open cluster in
Oh yeah,
Taurus.
it's lovely actually. That's Poniatowski's bull, isn't it?
Yeah, I've only ever seen it once actually, and that was because I came across it by accident because I was looking for some variable stars, and I thought, oh, it looks a little bit like the Hyades in the Taurus, and then I realised I've opened up the software, star charts outside, that's exactly what it is. And as you say, it's Poniatowski's bulls.
It's very distinctive, and of course, it's a good marker to that very famous star in our sky, which is Barnard's star, which is the star which has got the fastest proper motion across the sky. Proper motion is the term used to describe the apparent movement of a star against the background stars. This one is pretty amazing. It moves roughly half the diameter of the moon against the fixed background sky every 90 years, which doesn't sound like much, but it's moving along at a fair old lick, isn't it?
It's moving quite quickly. Should say though, at magnitude 9.5, you will need a telescope to be able to see it.
Okay, well, below Ophiuchus, we've got the bright orange star Antares as a supergiant star which marks the heart of Scorpius the Scorpion. And the binocular globular cluster Messier 4 sits 1.3 degrees to the west of Antares. And as you start going down there, you're sort of moving into a very rich part of the Milky Way, which is quite glorious. as we go through into summer, but not great in June because of the bright skies. It's probably better later on, isn't it, in July and August?
Yes, I think and that's something we'll touch upon in those virtual planetariums for July and August. But for now, there is plenty to look out for, especially those special events. Do check those out, and good luck for everybody for who tries to observe the partial eclipse. So thanks, Pete.
Thanks, Paul.